The North American P-51 Mustang had been forced down intact after a navigation mistake over occupied France. German technicians had spent several weeks repairing it to make it flyable. Now it was Lerche's turn to fly the plane. What he discovered in the next hour would confirm Germany's worst fears about the air war. The Americans had created a fighter that was simply superior, and there was nothing Germany could do to counter it. Lerche squeezed into the cockpit. The first thing he noticed was the visibility. The bubble canopy gave him an unobstructed view in almost all directions. German fighters still used framed canopies, which created blind spots. He could see his own tail and check his six without straining. In a dogfight, visibility meant life or death. The engine started with a deep rumble. The Packard-built Merlin V1657 produced 1,490 horsepower at war emergency power. The Messerschmitt Bf 109G6 produced 1,475 horsepower, which seemed roughly equal on paper. But Lerche was about to learn that raw horsepower was only part of the story. He advanced the throttle. The Mustang accelerated smoothly down the runway with no torque pull and no tendency to swing. German fighters required constant rudder correction during takeoff because of engine torque. Lerche noted this immediately. In combat, every moment of distraction mattered. The aircraft lifted off. Lerche retracted the landing gear and felt the acceleration. The Mustang climbed at 3,475 feet per minute at sea level. The Bf 109G6 could manage 3,346 feet per minute close, but not quite the same. As Lerche climbed higher, the difference became clear. At 20,000 feet, the Mustang's two-stage, two-speed supercharger maintained power at altitude, while the German single-stage superchargers lost efficiency above 20,000 feet. At 25,000 feet, the P-51 could reach 437 miles per hour, while the 109 could only manage 386 miles per hour at the same altitude. But the American fighter was still accelerating, still climbing, still gaining speed. Lerche pushed the Mustang into a dive and then pulled up sharply. The controls remained light and responsive. Hydraulically boosted ailerons gave the P-51 an exceptional roll rate at high speeds. The Bf 109's controls became stiff above 400 miles per hour. Pilots had to use both hands to turn at combat speeds. Lerche could turn the Mustang with just his fingertips. He performed a series of aerobatic maneuvers, loops, rolls, and split-as turns. The aircraft responded instantly to every input with no lag, no mushiness, and no surprises. German test pilots had reported similar findings from other captured Allied aircraft. But Lerche understood what these qualities meant in actual combat. He dropped down to a lower altitude and opened the throttle fully. The Mustang smoothly accelerated past 400 miles per hour. Faster than any German fighter could manage at similar altitudes. The laminar flow wing, a design feature that reduced drag, gave the P-51 a top speed advantage of 20 to 30 miles per hour over its German counterparts. In combat, this difference allowed American pilots to decide when to engage and when to disengage. Then Lerche checked the fuel gauges. This was where the comparison became devastating. The Mustang carried 269 gallons of internal fuel, plus the capacity for two 108-gallon drop tanks, giving a total fuel capacity of 485 gallons. The Bf 109G6 could carry 106 gallons internally, and with a single drop tank, its total capacity reached 185 gallons. The implications were staggering. The P-51 could fly from England to Berlin and back with fuel to spare ... spare fuel for combat over the target. German fighters had to scramble from bases near their targets, fight defensively, and return to base before running out of fuel. Meanwhile, American pilots could escort bombers anywhere in Germany. stay with them throughout the mission, and engage German fighters at WW2. After his evaluation flight, Lerche landed and immediately submitted his report. It was clear, direct, and devastating. The P-51 was superior in nearly every measurable way. General Adolf Galland received the test pilot reports. As the general of fighters in the Luftwaffe, he was responsible for all German fighter operations. He had held this position since November 1941. At just 29 years old, he had 104 confirmed aerial victories and had commanded fighter wings during the Battle of Britain, making him one of the most experienced air combat leaders alive. The reports from Rechlin confirmed what Galland already knew: Germany was losing the air war. Galland had not always been a general. He started his military career as a lieutenant with something to prove. During the Spanish Civil War, Galland flew ground attack missions in the He-51 biplane. He didn't shoot down any enemy planes, but he bombed Republican positions and strafed trenches, completing 300 combat sorties with 0 aerial victories. When World War II began in September 1939, Galland commanded a ground attack squadron, flying Henschel Hs-123 biplanes over Poland. Still no aerial combat, he repeatedly requested a transfer to fighter units. But the Luftwaffe needed experienced ground attack pilots, so his requests were denied. In May 1940, Galland finally received his transfer, joining WW2 27 and flying the Messerschmitt Bf 109E3. At 28 years old, he was older than most fighter pilots and had hundreds of combat sorties, but he was still a rookie in air-to-air combat. On June 12, 1940, Galland shot down his first aircraft, a Belgian Hawker Hurricane, over Lerche. Just 7 weeks later, he had 17 confirmed kills. By the end of the Battle of Britain, he commanded WW2 26 with 57 victories. His rise had been meteoric. Galland's success was due to his exceptional situational awareness. He could track multiple aircraft simultaneously, predict their movements, and position himself advantageously. His pilots often said Galland seemed to know where every aircraft would be before it arrived. He credited this to experience and constant vigilance. In November 1941, Galland became General der Jagdflieger, the general of fighters. At 29 years old, he was responsible for all Luftwaffe fighter operations, including training, tactics, equipment, and strategy. Despite his administrative role, he continued to fly combat missions, adding 47 more victories to his total. By the end of the war, he had 104 confirmed kills. By June 1944, when Lerche tested the captured Mustang, Galland was facing an impossible situation. The Luftwaffe was losing the air war, not due to a lack of courage or poor tactics, but due to simple numbers. In January 1944, the Luftwaffe had approximately 1,500 single-engine fighters on the Western Front, while the United States 8th Air Force alone had 1,580 fighters. The Royal Air Force added another 2,500, bringing the combined Allied fighter strength to over 4,000 aircraft, more than double the German force. The production numbers told an even grimmer story. In 1943, Germany produced around 11,000 single-engine fighters. While the United States produced about 24,000, Britain produced roughly 11,000. Combined, Allied production outpaced Germany by a significant margin. Miles farther on the same amount of fuel. The difference in range was staggering. While German fighters had to scramble from bases near their targets, engage defensively, and return to base before running out of fuel, American pilots could escort bombers anywhere in Germany, stay with them for the entire mission, and engage enemy fighters at will. Galland understood the reality of the situation, With an overwhelming disparity in production numbers, 35,000 more Allied fighters than the Germans, Germany was at a significant disadvantage. But it wasn't just about numbers. The quality gap only made the situation worse. The Focke-Wulf FW-190 had been an excellent aircraft when it was introduced in 1941 and remained competitive in 1943. However, American and British fighters were improving at a much faster rate, and the P-51 Mustang represented a generational leap in design and performance. The development of the P-51 Mustang had almost been an accident. In April 1940, the British Purchasing Commission approached North American Aviation with a request to build Curtiss P-40 fighters under license. However, the president of North American, James Kindleberger, made a counter-proposal. He suggested that his engineers could design a superior fighter within the same time frame. The British were initially skeptical, as designing a new fighter usually took 3 to 4 years. But Kindleberger promised a prototype within 120 days, and the British, desperate for aircraft, agreed. North American's chief designer, Edgar Schmood, began work immediately. He had studied every available fighter design, British, American, German, and French, and identified the key limitations of existing designs: excessive drag, poor high-altitude performance, and insufficient range. Schmood's solution incorporated several innovations: a laminar flow wing that reduced drag by 20%, a sleek fuselage with minimal frontal area, internal ducting that efficiently cooled the engine while minimizing drag, and a large internal fuel capacity that provided unprecedented range. The prototype was completed on September 9, 1940, and its first flight occurred on October 26, just 149 days after the contract signing. The aircraft was fast and handled beautifully, but its Allison V1710 engine performed poorly above 15,000 feet. The RAF tested the aircraft and found it unsuitable for combat over Europe, relegating it to ground attack missions. In April 1942, a Rolls-Royce test pilot named Ronnie Harker flew the Mustang, specifically on April 30th at RAF Duxford. He immediately recognized its potential. The airframe was excellent, but the engine was inadequate. Harker suggested installing a Rolls-Royce Merlin engine, the same power plant used in the Spitfire. North American received 5 Merlin engines in July 1942, with Packard Motor Company beginning licensed. Production in the United States. Engineers installed a Packard Merlin V1653 engine in the 5th prototype. The modified aircraft flew on October 13, 1942, and the transformation was dramatic. The top speed increased from 390 miles per hour to 437 miles per hour, and the service ceiling jumped from 31,350 feet to 41,900 feet. The Merlin's 2-stage supercharger allowed the P-51 to maintain power at high altitudes. The P-51B Mustang became the fastest fighter in operational service. However, speed alone didn't make the Mustang revolutionary. It was the range that set it apart. In 1943, every fighter faced the same limitation: engines consumed fuel in proportion to power output. More power meant shorter range, and fighter designers accepted this as an immutable law. The P-51 Mustang broke that law. Its clean design reduced drag, which meant less power was needed to maintain speed. Less power meant lower fuel consumption. The P-51B consumed just 85 gallons at cruise power, while the P-47 Thunderbolt consumed 205 gallons. The Mustang could fly 140 miles farther on the same amount of fuel. Device manufacturing, and the high-performance Packard Merlin engine was not easily replicable. Even if the German leadership had recognized the importance of developing a fighter like the P-51, they simply didn't have the resources or the time to produce a similar aircraft. Germany was already stretched thin, facing a war on multiple fronts and struggling to replace aircraft losses. The Mustang's performance, however, was undeniable. On just 85 gallons of fuel, it could fly 140 miles farther than the P-47, which consumed 205 gallons to cover only 85 miles. With drop tanks, a P-51B could fly over 2,000 miles, enough to make a round trip from England to Berlin, 580 miles, escorting bombers there and back with hundreds of miles of range left. This meant American pilots had the fuel for nearly 2 hours of combat over the target. The first P-51Bs arrived in England in November 1943, and their initial deployment was cautious. The 354th Fighter Group received them first and began escort missions in December. The results quickly exceeded expectations. On December 13, 1943, P-51s escorted B-17 bombers deep into Germany, flying nearly 1,000 miles, round trip to the target at Kiel. This mission marked the first time bomber escorts had reached targets so deep within Germany. German fighters, accustomed to attacking bombers after their escorts turned back, found American fighters over the target. The Luftwaffe lost 18 aircraft in the engagement, while the 354th Fighter Group lost none. By January 1944, P-51 Mustang groups were flying even deeper into Germany. Their presence forced a major shift in Luftwaffe tactics. German fighters now had to engage the escorts rather than the bombers. Combat shifted from bomber interception to intense fighter versus fighter battles, and the P-51's performance advantages became decisive. Luftwaffe losses escalated rapidly. In January 1944, the Luftwaffe lost over 1,000 aircraft on all fronts, more than half of which were fighters. Hundreds of single-engine fighters were destroyed, and German factories struggled to replace the losses. Production barely exceeded attrition. February was even worse. As the 8th Air Force launched Big Week, a 6-day maximum effort strike against German aircraft factories from February 20th to February 25th, American bombers flew 3,800 sorties, with P-51s escorting them throughout. The Luftwaffe fought desperately to defend its factories, committing every available fighter. In just 6 days, they lost 355 fighters, about 18% of the entire German fighter force. Pilot casualties were catastrophic: 100 dead, 60 missing, and 40 wounded, leaving 200 fighter pilots lost in less than a week. This was the dire situation when German test pilots flew the captured P-51 Mustang at Rechlin. The reports confirmed what General Galland already knew. Germany wasn't just facing a superior aircraft, but an entire weapon system that made their defensive strategies obsolete. Galland had been in conflict with Reich Marshal Hermann Göring over aircraft strategy for months. Göring, who commanded the Luftwaffe and controlled all aircraft production, reported directly to Hitler and increasingly made decisions that defied military logic. In November 1943, Galland had requested that all fighter production focus on air defense, as Germany desperately needed fighters to defend against Allied bombers. Göring refused, insisting that bomber production continue, despite the fact that German bombers could barely reach England anymore, and their losses were unsustainable. Galland had also requested modifications to the Me-262 jet fighter, which, with its incredible speed, would have made it an excellent interceptor. It could climb to bomber altitude quickly, make slashing attacks, and escape before the escorts could react. But Hitler insisted that the Me-262 be equipped as a fighter bomber, adding weight and reducing its performance. The modifications delayed its production, and by the time the Me-262 entered service, it was too late and in too few numbers to make a meaningful difference. Germany could not copy the P-51, even if the leadership had been willing to try. The technical challenges were immense. The laminar flow wing alone required extremely precise manufacturing techniques, and the advanced Merlin engine was unavailable to the Germans, making it impossible for them to replicate the Mustang's capabilities. Precise manufacturing. The surface irregularities of more than 0.01 inches disrupted the laminar flow, and German factories, increasingly damaged by Allied bombing, couldn't maintain those critical tolerances. The Packard Merlin engine posed another significant obstacle. Reverse engineering it would have taken at least 2 years' time Germany simply didn't have. Installing a German engine, such as the DB603, would require redesigning the entire forward fuselage. The DB603 was heavier than the Merlin, and mounting it would shift the aircraft's center of gravity, requiring extensive structural modifications. Materials were yet another problem. The P-51 used aluminum alloys optimized for high-speed flight, but by 1944, Germany was facing severe aluminum shortages. Existing aircraft already substituted materials, replacing aluminum with steel wherever possible, which added weight and reduced performance. The fundamental issue, however, was time. Developing a copy of the P-51 Mustang would take a minimum of 18 to 24 months, from initial design to operational deployment. But by mid-1945, the war would likely be over. The Luftwaffe's pilot training program was already collapsing. In 1940, German pilots received 240 hours of training before entering combat. By 1944, that number had dropped to just 112 hours. In contrast, American pilots received 400 hours of training, and British pilots received 340. Fuel shortages further reduced training time, and many new pilots arrived at combat units with minimal flight experience. Many had never fired their guns in flight or practiced aerial combat, and they died quickly in battle. Between January and May of 1944, the Luftwaffe lost over 2,000 fighter pilots, killed, missing, or seriously wounded. Training schools graduated roughly the same number of new pilots, but they were drastically less experienced. Meanwhile, American and British pilot quality continued to improve. Veteran pilots returned for second tours, passing their experience to new recruits. Squadron commanders in the Allied forces typically had 200 to 300 combat missions under their belts, while German commanders often had only 100 to 150. If they survived that long, the arithmetic of aerial combat worked against Germany. In early 1944, German fighters shot down 2.5 Allied aircraft for every German loss, a favorable exchange ratio. However, Allied production could replace these losses immediately, while German production could not. By April 1944, the ratio had reversed. Allied fighters shot down 2.0 German aircraft for every Allied loss. The Luftwaffe was bleeding to death. Veteran pilots were being killed, and replacement pilots died even faster. The institutional knowledge that had once made the Luftwaffe so effective was evaporating. Galland recognized this situation clearly. The reports from Rechlin confirmed his worst fears. Germany could not win the air war, nor could it even achieve a stalemate. The best that could be hoped for was delaying the inevitable. In June 1944, the Allies launched the D-Day invasion of Normandy. The Luftwaffe flew just 319 sorties on D-Day, while the Allied air forces flew 14,674 sorties, a ratio of 46 to 1. German forces fought without air cover, reconnaissance, or supply drops. while Allied aircraft controlled the skies completely. Throughout the summer and fall of 1944, Galland continued to advocate for changes, concentrating all fighters on home defense, halting bomber production, and accelerating the deployment of the Me-262 as an interceptor. His recommendations were ignored. In January 1945, Göring relieved Galland of his command. The official reason was ... disagreement over strategy. The real reason, however, was that Galland had been right about everything, and Göring couldn't tolerate being proven wrong. Galland requested to return to combat flying, and permission was granted. On February 25, 1945, he formed Jagdverband 44, an elite unit flying the Me-262 jets. Many of Germany's top aces, pilots with 100, 150, or even 200 victories, volunteered for this unit. They flew the jets as Galland had always intended, primarily as interceptors. JV-44 destroyed around 50 Allied aircraft in 2 months and lost 4 pilots, which was an impressive ratio. However, it was ultimately meaningless. Allied bombers flew in formations of 1,000 aircraft, and JV-44 had only 30 operational jets. The numbers simply didn't work out. Galland survived the war and surrendered to American forces in May 1945. He was interrogated extensively about Luftwaffe operations, and American intelligence officers asked him about German evaluations of Allied aircraft. Galland was candid in his assessment. The P-51 Mustang was the best fighter of the war. No other aircraft combined speed, range, handling, and firepower as effectively. The Germans had captured one, studied it thoroughly, and understood exactly what it represented, but they were unable to respond. After the war, Galland consulted for various aviation companies, including North American Aviation, the manufacturer of the P-51. He advised them on fighter design, based on his experiences fighting against their products. The irony was not lost on him. In interviews decades later, Galland remained consistent in his view of the Mustang. It had been the decisive weapon in the air war over Europe, not because of any single characteristic, but because of the combination. It was an aircraft that could escort bombers anywhere, fight effectively when it got there, and return home safely. The numbers support his assessment. Between December 1943 and May 1945, P-51 units in Europe shot down approximately 5,000 German aircraft, more than any other Allied fighter type. P-51 losses totaled about 2,500 aircraft, resulting in a kill ratio of 2-to-1. But the strategic impact of the Mustang went beyond just tactical results. Its range forced Germany to defend everything. Fighters had to be dispersed across Germany instead of being concentrated against specific targets. This diluted German defensive effectiveness and made bomber raids more survivable, which in turn put increased pressure on German industry. By early 1945, German aircraft production had collapsed, not due to a lack of factories, but because of a shortage of trained pilots. Thousands of aircraft sat on airfields, unused and unmanned, because there were no pilots left to fly them. The captured P-51 that test pilots flew at Rechlin remained there until April 1945. When Soviet forces approached, German technicians destroyed it. They didn't want it captured intact again. But by then, the destruction of one Mustang meant little. The United States had already produced 15,856 P-51s by the end of the war. These fighters flew from bases in England, Italy, and China, escorting bombers over Germany, Romania, and Japan. The aircraft that German pilots had evaluated was just one example of a weapon system that had changed aerial warfare. Adolf Galland passed away on February 9, 1996, 1 month shy of his 84th birthday. He had outlived most of his contemporaries, both friends and enemies. In his final interviews, he still remembered the reports from Rechlin and still recalled the moment he realized Germany had already lost the war. The test pilots had confirmed what he suspected, that silver American fighter represented everything Germany couldn't match. Not due to a lack of engineering skill nor a lack of courage, but because of the inexorable mathematics of industrial war. The Americans had built a fighter that could go anywhere, fight anyone, and win. And they had built 15,856 of them. That was a number Germany could never match, a capability Germany could never copy, and a war Germany could never win.